Andy, welcome back to Alien Space Education, your guide to the solar system and beyond. We're looking at another amazing planet, number 6 in our solar system, Saturn. Now, Saturn is magnificent because it's got rings. We can see some of the moons and has a very interesting, and it's a jewel of our system. It's light and fluffy, and yes, the atmosphere is amazing for this gas giant. So we're going to get straight into it. Please remember to like, subscribe, share, and keep spreading the love. Okay, so the base of Saturn. Saturn is the second largest planet in our solar system, coming just behind Jupiter. Its diameter is about 116,460 kilometers, or 72,367 miles. It makes up roughly 9.5 times wider than Earth. Despite its enormous size, Saturn is less dense than water. In fact, if you had a giant bathtub, it'd be big enough to float in it. So Jupiter is super heavy and really, really dominating in the solar system. Hence, the king of planets. Saturn, the queen of planets, is light and fluffy and very, very unusual for this reason. So how can Saturn be so heavy and Saturn be so light, yet Jupiter so heavy? Well, let's get into it. Saturn is a gas giant, like Jupiter, composed primarily of hydrogen and helium. Its atmosphere is thick and extends deep into the planet. Saturn day, known as its rotational period, is approximately 10.7 hours long. Remember, Jupiter is 9 hours long. Earth is 24 hours long. Okay, it's relatively short considering its size. So it's still very short considering how big it is. A year, Saturn's year is 29.5 Earth years. So it takes nearly 30 years to go around the sun once. Its distance from the sun is about 1.4 billion kilometers, or 870 miles. That is a very, very long way. So it'll take us a long time to get there. Saturn is known for its extensive and spectacular ring system. These rings are composed of countless particles of ice and rocks, varying in sizes from tiny grains to large chunks. These rings are incredibly thin compared to their width, with the average thickness only about 10 meters or 30 feet. So you think, when we look at Saturn, those rings that we can see very, very, in a very short, small period, they're only 10 meters, 30 feet, and yet we can see them. And if they're any thinner, they'd disappear. So they're very, very well balanced. So let's start off by looking at the rings of Saturn before we move into Saturn itself. The rings are undoubtedly its most famous feature. It's fascinated astronomers since their discovery in 1610 by Galileo. These rings are divided into several main groups, each with their own unique characteristics. These groups are labelled in alphabetical order when they were discovered. So in 1610, over 400 years ago, we could see these rings, and we've labelled them since then. So when you go, well, you think the alphabet A, B, C, and the ring A, ring B, as we labelled them, we did them as we saw them from the 1610s. So these are changed, and the order is not how you think it is. Outermost is the A ring, as it's called, is the outermost ring of the major rings, and is separated from the B ring by the Cassini division, a gap of about 4,800 kilometers or 3,000 miles wide. A ring contains several prominent ringlets and gaps caused by the gravitational influence of the moons. So even though the ring is so far away, moons are holding in place and putting a gap in there and influencing the colours and changes. The B ring, the brightest. So the A ring isn't that bright, but the B ring's the brightest and densest ring. Extends about 74,500 kilometers or 92,000 kilometers, or 46,300 or 57,500 from Saturn's center. So we're talking from the centre of Saturn to 46,000 to 57,000 miles. That's a big gap. That's a big variation they have from the centre. The B ring is thought to be made up of higher concentrations of particles, resulting in increased brightness and density. Now, what we see when it says brightness is the light reflecting off elements within these rings. Now, the most prominent thing that we see that reflects light is ice, because if you have ice here, reflect light off it, we put light on it, it reflects, and it's really, really bright. So there could be a lot of ice, but there could be a lot of other minerals there that we're not aware of. Iron, silver, things like that, that can be just as shiny and just as bright. What these are and how dense they are, we need to take a closer look. And we are planning to go back out there and have a look, so don't worry. The C ring, known as the creep ring, is much fainter and extends from about 91,000 kilometres to 117,500 kilometres, or 56,600 miles to 73,000 miles from Saturn's centre. It's less dense than the A and B rings and has a much more diffused appearance. So it's a little bit blurry, a little bit darker, but it's there. Those are the three main rings. Okay. Beyond these major rings, Saturn's also has several fainter rings, including D ring, which is the closest to the planet, and the E ring, which is located further out and is wider. It's the widest of Saturn's ring. The E ring is composed of microscopic ice particles and is thought to be maintained by the ice plumes from the moon Enceladus. So you got to think, Enceladus is injecting ice from its core, ice from it out into space. Saturn is holding it and keeping it in a faint ring. So these ice particles can't go anywhere, but be there. Enceladus could have created this ring just for us to see. Amazing. One of the most interesting aspects of Saturn's rings is the presence of gaps and ringlets. These gaps, such as the Cassian Divide, are caused by the gravitational effects of Saturn's moons, known as the shepherd moons, that help maintain the structure of the rings by confining the particles within certain regions. So what it's saying there is the rings are there on either side and the moon is in the middle. The moon is clearing the pathway, taking a beating, getting all the particles hitting it, but also as it's rotating around, obviously it's going at super speed and Saturn's spinning super fast. It's causing a push effect, so it's pushing particles away so they don't hit. And it pushes so many away, they don't hit it, but other particles will get through, while at the same time it's keeping that divide. So we see those ringlets, these gaps. It's really interesting how space and how gravity of a moon can affect such things as the little rings like this. Going on to Saturn's atmosphere and weather, this is where Saturn gets interesting. Saturn's atmosphere is dynamic and complex environment, characterized by its striking appearance and turbulent weather patterns. The atmosphere is composed mainly of hydrogen, 96%, give or take, helium, about 3%, and trace amount of methane, ammonia, and other gases. So we're only talking about 1% of the main other things. Whereas you looked at the other planets, when we talked about this atmosphere, we've always added up to 100% and trace elements. Saturn is only 99% plus 1% trace elements. That's a big difference to what these trace elements will have an impact. One of the most notable features of Saturn's atmosphere is the banded appearance. Similar to Jupiter, these bands, known as zones and belts, are caused by differential rotation and convectional currents within the planet's atmosphere. These bands are divided into lighter coloured zones and darker coloured belts, which are the result of varying wind speeds and chemical composition. Just like Jupiter, they're spinning super fast, and the heat will rise and they get lighter and they fall and they get darker. But the wind speed to each band is different depending on how fast it's spinning and how fast that wind is going. Saturn experience some of the most intense wind speeds in the solar system. Wind speeds can reach a speed of up to, wait for it, 1,800 kilometers per hour or 1,100 miles per hour near the equator. These high winds contribute to the planet's characteristic band structure and create powerful storms. And that's why we're seeing these different colours. These speeds are hugely fast and hugely dangerous. They don't touch. The speeds on there are a lot more dangerous than our tornadoes. One of the most remarkable features of Saturn's weather is its presence of a hexagonal storm system at the planet's north pole. The hexagon is a massive, persistent cloud pattern with a unique six-sided shape. This hexagon, believed to be a result of a stable, rotating atmospheric jet stream, and has been observed in detail by the Cassini spacecraft. So we've looked at this hexagon. How and why it's shaped like a hexagon, we don't know. We do know it's a storm. We do know it keeps spinning. We do know it's there. But why a hexagon shape? Why has it got sides? I couldn't tell you. We don't have that knowledge yet. Just like Earth, Saturn also experienced changes due to its axial tilt of about 27 degrees. As Saturn orbits the Sun, it pulls and receives a varied amount of sunlight, leading to changes in atmospheric and dynamic weather patterns. These seasonal effects and affect the appearance and behavior of the planet's rings and storm system, just like Earth. We have a tilt, Saturn has a tilt. We have a complex weather pattern system. Saturn has a complex weather system. So there are similarities between us, but how big it is and how fast those winds are and how fast it spins makes a big difference to the weather pattern it receives. And just like our weather forecasts try and predict our weather, imagine trying to do it on something that big. They're in for a job. Maybe you could help with that one day. Saturn moons are very diverse. They're very different. Whereas we only have one, Jupiter has over 90. Saturn has some very unique moons. They're incredibly diverse, with over 100 known moons, ranging in size from tiny moonlets to the massive Titan. So let's explore some of the most interesting and significant moons of Saturn. Obviously, we start with the biggest one, Titan. Big, powerful. Saturn's largest moon, which is also a moon in the solar system. Titan is unique because its thick atmosphere comprised primarily of nitrogen with traces of methane and hydrogen. The atmosphere creates dense orange haze and obscures the moon's surface. Titan is known for its lakes and seas of liquid methane and ethane, which make it the only moon in the solar system with a stable surface liquids. Titan's atmosphere and surfaces have drawn significant interest from scientific study, from significant interest from scientific bodies, including prebiotic chemistry and potential habitability. Okay, so because Titan's so far away, it's orbiting Saturn, yet the moon has liquid ethane and methane on the surface. No other planet has that. No other moon has that except for Earth. We have liquid water, but the moon, so far away, has liquid ethane and methane. That's really, really intriguing and really interesting. Could there be life in that? Wouldn't be life as we know it. We wouldn't know. So that'd be really interesting because, see, there's no oxygen. Has a nitrogen, which we need nitrogen and oxygen in order to survive. So what would life be like on Titan? How would it vary? Given it's got liquid but not water, H2O, it's got ethane and methane. That could make some interesting discoveries. It could change how we think about life on Earth as well. Another intriguing moon is Enceladus, which has gained attention for its for its geysers of water vapor and ice particles. I mentioned these earlier. These geysers erupt from the subsurface oceans, making themselves one of the top candidates for the search of extraterrestrial life. These plumes contain organic molecules and salts, providing clues about the moon's potential habitability and internal structures. Even though Titan has liquid on the surface, Enceladus has liquid water under the ice, and it's very deep underneath. And there is a mission to go there and study this. But these plumes are coming from underneath the surface through 6 sheets of ice. So they're so powerful they've got to break the ice and go through. But because in atmosphere, these plumes are going into space and then helping cause the E-ring. So it's really interesting how these all work together. And if Enceladus keeps these eruptions going, these plumes going up, will it run out of water to carry on making these rings? I don't know. Do you? Moving on. Another one, Rhea. One of Saturn's largest moons is covered in ice and has been heavily cratered surface. Rhea has faint rings that were discovered by the Cassini spacecraft, making it one of the few moons with its own ring system. These rings are composed of ice particles and are very faint, making them challenging to observe. So, Rhea, another giant moon around Saturn, in or close to these rings of Saturn, but it's able to create its own rings and pull some of that debris. They're a lot smaller, a lot thinner, which makes them incredibly hard to see. By the way, I've been told they're made of mostly rock, so therefore they're incredibly hard to see. There's not much ice in there. Despite being covered in ice, it's a shiny moon. We can see it because the light reflects off it. But the ringlets are really, really hard to see. And that can only be because they're dark material and very, very thin. What do you think? Then we have Leptis, another fascinating moon with its unique features. A dramatic colour difference between its leading and trailing hemispheres. The leading hemisphere is much darker, while the trailing hemisphere is brighter and covered in ice. A stark contrast is thought to be the result of material from the moon's own rings accumulating on one side. So the rings, it's got half rings on one side. Light is hitting one side, the rings are on the other side. But why is it dark? Why is it light? Why we only see this certain ways? Not 100% sure myself. We're going to have to look into it. Maybe in a future episode I'll go in real detail on this. And finally there's Minos, often called the Death Star moon. If you've seen Star Wars, you'll know the Death Star. This moon looks like it. The moon is a massive crater called Herschel, which is about 1/3 diameter of Minos, and gives it its distinct appearance. That's why it's on the list. It's a small moon, but 1/3 of it has a massive crater that makes it look like the Death Star from Star Wars. Maybe it was the inspiration for the Death Star. I'm not sure, but it's really interesting that science fiction can take inspiration from science fact. And it's interesting how science today is inspiring science fiction and vice versa. Exploring Saturn's past, present and future. Saturn has been a major target for exploration, with several spacecraft providing valuable insight into its planets and moons. The exploration of Saturn has enhanced our understanding of the gas giant and its ring system. Firstly, the first spacecraft to visit Saturn was Pioneer 11, which flew by in 1979, provided close-up images of Saturn's and its rings. The spacecraft confirmed the existence of the rings and began to unravel their complex structure. Over 50 years ago, we were looking at the rings then. Following Pioneer 11, obviously, Voyager 1 and Voyager 2 used it, conducted flybys of Saturn in 1980 and 1981, respectively. These missions provided detailed images of Saturn's rings, discovered new moons, should we say, and offered the first close-up views of Titan. The data collected by Voyager significantly advanced our knowledge of Saturn's rings. and the moon satellites. So we're talking Voyager 1 and Voyager 2 really helped pioneer 11 and our understanding by keep going back. Next we had, in 2004, was a Cassini-Heinrich spacecraft, which spent 13 years studying the planets and its moons. Cassini provided detailed images and data of Saturn's rings, dynamics, atmospheric dynamics, moons, and it also carried the Hyginus probe, which landed on Titan in 2005, providing the first direct observations of the moon's surface. Now, I will be linking on my website, Space for All Education, images from this so you can actually have a look for it. Cassini's mission revealed so much about Saturn's moon system, including the geysers from Enceladus and the complex season changes on Titan. The spacecraft's data has been crucial in shaping our understanding of Saturn's and its environment. It's 13 years studying it, and we're still looking at this data, and we're still going over it in case we miss anything, and we're still learning new stuff, because every time we look at it, we see new things. It's looking at images, and you look at it, you look at it, and you discover new things all the time. Looking to the future, there are currently missions to return to Saturn, but the data from Cassini and other missions will continue to be analysed for years to come. Future missions may focus on further exploration Titan and Enceladus, and the potential seeking and understanding the conditions for life and the process of shaping Saturn's rings and moons. Because the rings and moons, even though they're there, they are changing. They're changing colour, they're changing shape, but they're there. They're there for millions of years. Now, are they shrinking? Are they getting smaller? Or are they expanding? We know the outer ring is expanding because Enceladus is still sending out jets of ice. So that ring will get brighter and brighter and be more prominent. But what about these other rings? Will they, because they're rocks, will they create new moons? Will they collide, and these rocks will collide and produce their own gravity and produce new moons, which means the rings will gradually shrink as new moons come into existence? Or will they spread out? Will some of the moons that are already there break apart under the pressure of Saturn and create new rings? Saturn is fascinating, and these things are happening right in front of us. To understand it, we have to do a lot of studying, and it's going to take a lot of work. I hope, as I get more data and as I carry on these podcasts, you will keep wanting to learn more and you'll keep listening. So, to sign off on this episode, as we wrap up our exploration of Saturn, it's evident that this gas giant is a planet of breathtaking beauty and complexity. From its magnificent rings to its diverse and intriguing moons, Saturn continues to captivate scientists and space enthusiasts alike. Study of Saturn not only ensures our understanding of the solar system, but also inspires curiosity about the broader universe. As we look forward to the future discoveries and missions, Saturn remains a shining example of the wonders that our solar system has to offer. I'd like to thank you for joining me on this episode. If you enjoy our journey, this ringed giant, be sure to subscribe, rate, leave a review, ask me questions, leave a comment. Go to spaceforalleducation.com, look up more information there. There's lots to learn, and I'm only scraping the surface of how much we know. Please keep looking up, keep being curious. Remember, the cosmos is full of marvels waiting to be discovered. I look forward to you listening and joining me for the next episode soon. Take care.